Hi everyone, I'm Dr. Subbarao from RVIT Institute of Technology. In this video, I'm going to explain superconductors. First of all, we have to see the definition of superconductors. Superconductors are the materials that conduct electricity with zero electrical resistance whenever it cooled the below specific temperature, which is known as a critical temperature. So, the superconductors are the materials which offers zero resistance are called the superconductors. And here the electricity can flow through them without losing any energy. That means it passes 100% energy and effectively creating the pathway for continuous current flow. If you see, this is the normal metals. Normal metals, for example, copper, aluminum. These are widely used in electrical conducting materials. So all the conducting materials are having the metals. That means copper. If you decrease the temperature of the conducting material, what happens? If we decrease the if you decrease the temperature of the materials, then the conductance of the materials also decreases. And here the normal materials reaches the minimum conducting value at absolute zero, but the conductance never becomes zero. So the normal metals, the normal conductors having minimum conductance at absolute zero, they never becomes zero. In case of superconducting materials, if we decrease the temperature of the superconducting material, then the conductance also decreases. Whenever it reaches to particular temperature, at that temperature, the properties will be changed. That means the superconducting material loses its superconducting property and the conductance of the material becomes zero. So the temperature at which the material loses its superconducting property is known as a critical temperature. This is denoted by the Tc. After this Tc, the conducting material having the zero conductance. That means the total conductance of the material becomes zero, which having the high resistance. In case of resistance, we can say that the superconducting materials offers a zero resistance. That means they are not having any resistance to stop the flow of electric current. But after the reaching the this critical temperature, they offers the maximum resistance. That means the conductance becomes zero. They never allow the passage of electric current through them. So this is the superconducting materials. Now coming to the properties of superconducting materials. The first one is the zero electrical resistance. Unlike regular conductors, the superconductors offers no resistance to the flow of electricity whenever it becomes the below the critical temperature. So this is applicable when the superconducting material having the temperature below the critical temperature. Then only they offers the zero resistance. And the next one is the critical temperatures. Different materials having the different critical temperatures. So the critical temperature depending upon the nature of the superconducting material and the atoms present in the superconducting materials. So different superconductors having the different critical temperatures. All do not have the same critical temperatures. And the next one is the Misner effect. Misner effect means when the superconducting material is exposed to the magnetic lines. That means when it is placed in a magnetic field, then the magnetic lines of forces passes through the materials. Here, the superconducting material acting as a perfectly diamagnetic in nature. That means it expels the magnetic lines of forces. Now, what is a Misner effect and how it will affect the superconducting properties? When superconducting material is cooled below its critical temperature, it becomes a resistance very less and acting as a perfect diamagnetic material. That means it has the diamagnetic in nature. And when superconductor is placed inside a magnetic field in a critical temperature, all the magnetic flux is repelled. That means it will expelled out from the effect of the magnetic field. This effect is called the Misner effect. And a perfect diamagnetism arises from the sum of the special magnetic property of superconductors. And the next one is if there is no magnetic field inside the superconductor, the relative permeability or the diamagnetic constant becomes zero. That means if the material having the zero conductance, that means it will never conduct the electricity, and the permeability of the magnetic value becomes zero. And the next one, I am showing the diagrams here. If the temperature below critical temperature means it is acting as a diamagnetic property, hence the conducting material repels the magnetic flux. And if the temperature of the material is above the critical temperature, then it affected by the magnetic lines of forces. And the next one, examples of superconductors: mercury, lead, and some of the alloys. The alloys are made with a combination of metals. So these are the examples of classical superconductors. And there is another category, high temperature superconductors. So copper oxide, molybdenum oxide, titanium oxide, these are the examples for high temperature superconductors. Now coming to the applications of superconductors. These are used in MRI scans. MRI means magnetic resonance imaging. So these are used in medical field. Here these superconductors are crucial for creating the powerful magnetic fields in MRI machines. And the next one, high speed trains. These superconducting materials forms the magnets, powerful magnets. Those allow the trains to levitate and travel at high speeds. And the next one, power transmissions. Superconducting cables can transmit electricity with the minimal loss of energy in power grids. That means they have the zero resistance. They conduct the total electric current without loss of any electrical energy. Next one is the particle accelerators. These superconducting materials are used to guide and accelerate the particles in research. So these are the applications of superconductors. Now coming, what are the challenges faced by construction of the superconductors? The first one is the low temperature requirements. Most superconductors requires extremely low temperature to function, making them expensive and challenging to use. That means almost superconductors are having the low temperature. Whenever it have the low temperatures, they have the high efficiency to conduct the electricity. So for making such kind of superconductors, the process is highly expensive. That means high cost materials were used for the construction of such kind of superconducting materials. And this one is making the challenge to the construction. And the next one is the developing high temperature semiconductors, superconductors. So the research is going on. Still the research is going on to construct the high temperature superconductors. So these are the challenges for constructing the superconductors. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.